number 11, we've got vertices and co-vertices. So that's definitely an ellipse. We can see that here. So this means then let's figure out how this is oriented so I can see which numbers will go underneath where and where the center is. Okay. Notice they're all equal to 1 because that's its standard form. All right, so let's see, I'm at 29 and the negative 10, 9. So I'm way, okay, I'm not even going to draw this as scale. I just want to visualize where everything is. I can't handle like a stream of numbers like that. I have to kind of know where everything is. So let's say that we're at 20 and then we're all the way at 9, and this is definitely not the scale. And I'm going to just stop saying that because none of this will be the scale. Okay. Now a negative 10 here. Okay, now what this does is it allows me to think, all right, so this means that I'm going, my center is somewhere in the middle here. Okay, so let's find this whole distance. The whole distance is 30, okay? So the whole distance from negative 10 to 20 is 30. So this means that the exact middle would have to be 15 this way and 15 that way, okay? Because half of 30 is 15. So he's going to be right here. Now 15 this way would be at 5. So my center has to be at 5, 9. Okay. And notice how I almost wrote 9, 5. I have to be very careful with this because I can easily switch them around because of me just looking at this thinking that's the x coordinate. You have to be really careful when you're doing this. Maybe you don't have that problem. I know that I do. So it looks like all of these are, nope, we're able to scratch out a couple of these. We can get rid of the ones that are plus because we know that we're shifting over to the right. So this guy and this guy. Okay. Right? Yeah, okay. So we can get rid of those two. Now we're down to 3. We just got to figure out which is which here. So we went up here. So this distance being 15, which means that 15 squared should be underneath the x. That's 225. Okay? So this means that here and here have to be the case. So it cannot be him. So now, do I have 25 or do I have just 1? So let's check out and look at the co-vertices. So it looks like if I'm at 514, let's see, 5, I'm all the way up at 14. That actually should be enough. I'm actually, how far is that, 5? That's a distance of 5. I don't even need to know where this guy is. I know he has to be 5 this way in order to be an ellipse. So, and it looks like 5 that way would produce, yeah, that would put me at 4. So, knowing that distance is 5, okay, what I need is just square it underneath, so that would be that 5 squared, okay? All right, now maybe you couldn't get that problem quicker than what I just did. Cool. I need to write it out because I need to be very careful with this stuff. I make really easy mistakes with this kind of stuff. Okay. All right, so vertices, now I got a foci, and now I'm going to be using that foci to figure out where my co-vertices are. So this is going to be an extra step, all right? But let's take a look here. Let's figure out where we are first, and then we'll worry about how the foci fit into everything. I'm at 110 and then negative 15 tenths. So I'm way over here. Okay, so 1, here's negative 15, and I'm all the way at 10. So here's that and that. Now maybe I can use the process of elimination here, and foci won't be too big of an issue. Okay, but I'm going to run through it as if the process of elimination can't be used, just in case you run into that barrier when you're taking your test. Okay, so where are we at? We are. This is a total distance of 16. Okay, total distance of 16. So this means I'm going to be going 8 backwards this way. Okay, so that means my y coordinate is still 10, but that puts me at negative 7. Okay, so this means that my center is at x plus 7 squared plus y minus 10. Okay. Plus 7 minus 10, plus 7 minus 10, plus 7 minus 10, nope, can't have that one, plus 7 minus 10. Okay, so we can get rid of that guy. Now, what goes underneath what? So if this guy goes from, this is a distance of 8, okay, that means underneath the x-axis we will put 64. Okay, will that eliminate 1? 1, 2. Okay, so now we got A and E left over, and then we'll figure out, is it 4 or is it 9? Okay, now here's where the focus comes in. Okay. So let's look at that number carefully. The advantage of putting a plus radical 55 and minus 55 is that you actually know that radical 55 is your C value. Okay, that is the distance from your center to the focus. Okay, now I'm not even going to graph this. I know that with an ellipse, okay, C squared equals the bigger one, the major axis value, minus the smaller one. Okay. Now normally we have the square. If I wanted to solve for C, I would actually put the square root. Okay. But what I can say then is that when I take the square root, I get 55. So that means he has to be 55. Okay. It also means that the larger one, my vertices, that distance is actually 8 squared. So that means this, A squared, is 64. Okay? Now you really don't need to overthink it now. 64 minus what gives you 55? It's got to either be 4 or it's got to be 9. Okay, 4 or 9. Now if I subtracted 4, I should have a radical 60. Okay? But for me to get from 64 to 55, I need to subtract 9. So that means I don't even have to take the square root. Just leave it. 9 is your B squared. Okay, 9 is your B squared. Okay, so the answer for this guy is E. So again, you don't try not to let this formula mess around with you too much. That radical means that 55 is the number, that's the distance between the B squared and the A squared. It has to be 55. Okay. Okay, so identify the vertices here. Since this is a hyperbola, we're going to move over. We're going to go up. We're going to go down 5. And we're going to move on the x. So 1, 2, 3, 4, 5. Okay, right here. Okay, now that is the center. Okay. And then on the y, what we're going to do is we're going to go up this amount, but we need to take the square root. Okay, so here is the center at 0, negative 5. And now we're going to go up radical 30. Okay, now that's 5 point something. Okay, so we're like right about there. And then we're going to go down this way. All right, now this distance is radical 30. Okay, same, so is this. All right, now the reason why we know that these are the vertices is because for a hyperbola, the vertices are on the actual graph. It doesn't matter which one of these is larger like it does for an ellipse, okay? For an ellipse, it does matter which one of these values is larger, okay, for the vertices and covertices. What matters for a hyperbola is which value is underneath the first expression, okay? This first expression is y, and this guy has to be where the vertices are not, okay? E actually moving over is just going to be helpful for when we want to graph, okay? But at this point, we know that this guy, because the y is squared, we know he has to open upward. And those are where the vertices are. That's why there's no co-vertices with hyperbola, because they don't actually exist. So with this then, what we got to do is we got to figure out where that is and where this is. Now notice that they both have the x-coordinate of 0. Okay? But what's nice about this is that we know that we start here negative 5, okay, for our center. But if we're going up radical 30, all we really have to do is look at it like this. You're going up radical 30. That's the nice thing about having it in these forms. If you had it in decimal form, you can't see it. You'd have to like calculate what the radical 30 is like every time. All right. This guy, you would subtract radical 30. So it's actually, for mathematicians, they like to actually use this expression because it's actually more exact than using a calculator and getting decimals. Okay, so this is actually the vertices because there are no covertices, and for a hyperbola, and that's all that they're asking here. All right. 14, identify the foci. All right, let me say that for the next one.